Hello world, let's learn to identify expression. Let's start off looking at some of the binary operators because I think they may be the easiest to recognize. Of course, C++ has the addition operator, taking two operands, in this case weight and donut. Of course, there's also division, people divide by politics. There's an operator for increment and assign. In this case, hamburger is going to get the value of hamburger plus lettuce, so it's going to add lettuce onto the hamburger. We can take the bitwise conjunction of two operands. So in this case, Jim Carrey is going to bitwise and with the mask. We can multiply. Triple times food. We can compare. You is less than me. If we want to do a comparison of two objects for equivalence, then we can use the double equals operator. In this case, a single equals would be an assignment. These are a subset of all the binary operators. Of course, there are the other comparison operators, greater than, less than or equal to, greater than or equal to, not equal to. There are other bitwise operators. There's other forms of assignment, etc., etc. I don't want to go through all of those. There's also a group of operators called unary operators. These operators group right to left. There are some of the more familiar ones, prefix version of increment by 1 or prefix version of decrement by 1. There's the dereference operator, star readers here. Take an address stored by this ID and dereference it and give me the value that is at that address. Ampersand operator will give me the address of my house, so that way I can get a pointer that I can then have to dereference later. The Unary form of mathematical negation, the negative sign. So here I have a negative charge. Or I can have the corollary, unary plus. The only thing it actually does is integral promotion. Otherwise, it just evaluates to the value in this expression. I can have the bitwise negation here. This is not my bits. This form of negation is the logical form. So this could be read as not this time. There are some familiar but perhaps less obvious expressions that I want to point out that are also unary operators. I can get the size of some other expression or value, x. New and delete and all of their various forms are also forms of unary operators and are thus themselves expressions. And then there are these perhaps less familiar looking expressions, a line of and no except. They look like function calls, but they're actually operators, just like size of. There's a whole nother group of expressions called postfix expressions. They're going to look a lot like the unary expressions, except these group left to right. Within this category are things like subscripting an array, making a function call, the function form of casting. In this case, I'm converting x to the type to convert to. It's the means by which you access the members of a variable, either through the dot operator if you have a non-pointer, or through the arrow operator if you have a pointer. The postfix increment and decrement operators are postfix expressions. There's this funny looking function call like operator called type ID, which will give you the type info associated with the type of the expression that's given to it, in this case t. And then there are these C++ forms of casting that themselves look like template functions but are actually operators. In this case, we are dynamic casting Clark Kent to a Superman. We are static casting my Ford to a car pointer. We can reinterpret cast the Constitution to a SCOTUS decision. Or we can const cast a const time object to a time pointer. And of course, there must be more. There's the ternary operator, which is the only expression which is capable of doing some form of selection. In this case, I'm asking the question, am I really hungry? If yes, then I want a medium pizza. Otherwise, I want a small pizza. Throwing is another type of expression. In this case, I'm going to throw an exception called baseball. And there's also the comma operator, a lesser recognized operator, but one that exists. It evaluates left first and then the right side of the comma operator, and then the whole thing will evaluate to whatever the value of the left side was. So far I've been showing the operators in terms of having identifiers on both sides, like hamburger and cheese. But it turns out that we can have expressions on each side of these, and that hamburger and cheese themselves, as identifiers, are themselves also expressions. This allows us to do things like chain together a bunch of expressions into one. Now I have hamburger plus cheese plus lettuce plus tomato minus 3 bytes is equivalent to satisfaction. In this case, this operator has identifiers for both of its operands, but the second plus operator has the result of the first addition, which is itself an expression, and an identifier as its second operand, in this case lettuce. The third plus is going to have the result of the expression hamburger plus cheese plus lettuce, that whole expression, plus this identifier tomato. And we're going to get to the subtraction operator, which is going to have the result of this whole expression here minus the result of this multiplication. That's because this multiplication has a higher precedence than the subtraction does. So we'll evaluate this entire expression and this expression, and then we're going to subtract the two of them. Once that is done, we will test whether or not that is equal to whatever this identifier is, satisfaction. The multiplication operator here, I should note, also has an identifier on one side and a literal on the other. And that leads us into a talk about primary expressions, because IDs and literals are two forms of primary expressions, but there are a few others. As we just saw, literals and IDs are both forms of primary expressions, but there are also parenthesized expressions, lambdas, and fold expressions. Putting parentheses around an expression makes it another expression. The reason that that is made a primary expression is because that is elevated to make it the highest operator precedence there is, so that you can control explicitly exactly how you want a bunch of other expressions to be ordered. The other two forms of primary expressions, lambdas and fold expressions, I'm not going to cover in any detail here, as they both warrant their own discussions entirely. But it is worth noting that they themselves are also forms of primary expressions and have grammatically the highest precedence in the way the language parses out.